Hello, this will be a short video on similar shapes and discussing what they are and what we can do with them. So first off, what are similar shapes? Similar shapes are two shapes that have the same properties, angles, and basically the same shape but they're a different size. So when you're looking for similar shapes, what you're looking for is an enlargement between two shapes, and they keep the same properties they had before, and all their sizes, because obviously as I said the size gets different, all their sides remain in the same proportion. So for example, if a square goes from having sides of 2 centimeters to 4 centimeters, all the sides will keep that same proportion. So all squares and all circles are similar shapes regardless of their sizes. They all keep the same proportion of sides, they all keep the same angles, they all keep the same properties. Two rectangles, however, can be similar, but it's unlikely they're not. So for a rectangle to be similar, it needs to have the same proportion on both sides. So for example, a rectangle with 2 and 4 centimeter sides needs to go to 4 and 8 centimeter sides, or keep proportions like that. You can also have shapes flipped on their side, and that's totally fine. So if I get this random bit of card, that to that, they're similar shapes, just flip round. Again, if you enlarge it and keep the same proportions, it'd be a similar shape. So, as I said before, an example of a similar square would be sides of 2 centimeters to sides of 4 centimeters, or sides of 1,000 to sides of 1,000,000,000. You know, they keep similar shapes. So all of those four squares I just said are similar to each other. So if you've got a missing side and you want to work out, and you know the two shapes are similar, so someone says, I've got these two similar shapes. The first one is a rectangle with sides 2 centimeters and 3 centimeters, and the other rectangle has sides 4 centimeters, and I don't know the other one. You work out that the ratio between the two is 2, because to go from 2 to 4 you need to times by 2. So you can then times the side you've got by the ratio and get to 6 centimeters. So how do you check if certain shapes are similar? So we're going to talk a little bit more about triangles in detail and see how you can work out if two triangles are similar. So the first one is if you know all the angles, and all the angles are the same across the two triangles. Regardless of the sizes of the sides, if the angles are the same on the triangle, the two triangles will be similar. If you also know the three sides on the triangles but not the angles, and all the sides are in a proportion, so for example if one triangle is 2, 3, 4, and another triangle is 4, 6, 8, you can see they're all in the same proportion, they all have a ratio of 2, and you can say that those two triangles are similar as well. The final thing you can do to check if two triangles are similar is if you know two sides and one of the angles, and the two sides are in proportion and the angle's the same, then you can work out from that the two triangles are similar. So what else can you do with similar shapes? How do you know more about similar shapes? So you can look at areas of shapes. So again, if we take two squares, because squares are nice and easy to work with, and you have a square with sides of 2 and a square with sides of 4, you work out that one of the areas is 4 and the other area is 16. So the difference there is 4, so it's not, you're not timesing by the ratio. Obviously the linear ratio, as it's called, for the sides is 2 there, so it doesn't seem to work, but the way to work out the area between two similar shapes is you square the linear ratio. So we worked out that the ratio between the sides is 2, because 4 over 2, so you get to 2. And then if we square that number we got, so we get the 4, and we can times the original area by that 4 to get the new area. So does it work for volumes as well? Well, sort of. You have to go a bit further. So if we again look at two cubes this time, so one is 2 and one is 4 again. The original cube has a volume of 8 centimeters cubed, and the new one has 64 centimeters cubed. Yeah, I'm check myself there, but yeah. So again, the linear ratio is 2, but the difference between them is times by 8. So hopefully some of you will be able to spot that's 2 cubed. So basically, the ratio of volumes is the same as the linear ratio cubed, and the ratio of area is the same as the linear ratio squared. So you can do that, and it's not just squares and cubes, it's with any shape. So you can do it with triangles, spheres, octagonal based prisms, 2D shapes, 3D shapes. You can do it on the face of a 3D shape. So for example, on a cube you could just take one of the faces and work out the areas. So it's any shape, but obviously cubes are the easiest to work with. You could do it quite easily with spheres as well. You could do it on sifts, areas of prisms and everything. So I hope that made sense to you, and I hope you know a little bit more about similar shapes, and thank you for watching.